Hey guys, welcome back. Yeah, sure. So it's chapter 4 now. We totally skipped chapter 3. Chapter 3 isn't very helpful until we get into Gen Chem. So today we're gonna go over acids and bases. So you need to know that there's two different definitions, Lewis, and then you have the Boster-Larry definition. So you need to understand that the Lewis definition, we're talking about electrons, and then the other definition, we're talking about hydrogens. So if we take a look, you see here, we're moving these electrons, right? So your base is going to be the acceptor. So your base is going to accept this guy. And then you could think about this guy here. It's like giving himself up to the base. So we call him a donor. Okay. So your base is taking away. So it accepts it. And then obviously, your acid is, Lewis, acid electron acceptor. Yeah, sorry. Your acid is going to be taking, is going to accept the electrons from the base. That makes more sense, right? So your acid is going to accept the electrons from the base. So it is an electron acceptor. The base is going to donate the electrons. So it is a electron donor. And it's sort of the same way with this definition here. We see here that, again, instead of electrons, we're focusing on the movement of hydrogens. So this here, this acid is a donor, and then this here, the base, is an acceptor. So the acid gave away its hydrogen to the base. Okay, so acid is going to donate the hydrogen to the base. So a few more things Kaplan wanted you guys to know is Ka. So Ka is how strong your acid is. The higher Ka, the stronger your acid. And the way Ka is calculated is literally the same way as we do KEQ, but instead we're just going to use our acids. So definitely note this. This should be pretty much review for everyone. So next, Kaplan, we talked about the pH and the pKa scale. So you need to know that pH plus pKa equals 14. And then a very simple question was find the pKa when the pH is 10, just to show why we need to know this, right? You're not going to get a question this easy on your MCAT. But you see how we can now use this equation to solve for pKa when we're given the pH. So a lot of times a lot of questions you'll see is you would have to find the pH and then use this to solve the pKa. And then you should also know, I wrote it twice. You should also know pKa equals log base Ka, negative log Ka. So log base 10 Ka. Okay, so these are just equations that are pretty important. And then one last thing that we need to go over are, so the lower your pKa, the higher and the stronger your acid. Okay, low pKa, strong acid. But now you have to remember this backwards. The stronger your acid, the weaker the conjugate base is. Okay, so strong acids have high pKa's. Weak bases also have high pKa's. Okay, and if you go under weaker acids, sorry, I said it wrong. Strong acid have lower pKa's. Now, if we go here, weaker acids have higher pKa's, but a weak acid is a stronger base. Okay, and pKa values, you've either learned them in class or you have some idea. I don't really think it matters if you memorize all your pKa values. I really think the idea is what you guys should be understanding is stronger acids, weaker base, weaker acids, stronger base, and done. Okay, so that's it for acid and base. So next chapter we're going to do nuclear. I have somebody who's waiting for this. So bro, you better lock in, okay? Better lock the fuck in.